This question seems complicated as well. I'm going to let you try a bit. Okay, find angle Y and angle Z. So how are we going to find part A and part B? Okay, in this figure, we know A, B, O, D is a trapezium. So that means there is a pair of parallel lines. And what do they tell you? AB is parallel to DO. So every time when we look at the question, we indicate the key points. Okay, whatever we can label in the diagram, we label. GFH is an isosceles triangle whereby FG is equals to FH. So this is where the lines are equal. Then BGFC is a rhombus, which means this length, okay, has to be equal to this length, equals to this length, and equals to this length. Okay, these are the important points, important things that we need to do in order to try and solve the question. Then part A, we are asked to find angle Y. Okay, angle Y is here. We know it's part of this isosceles triangle. So if we can find this angle here, okay, if we can find this angle here, we will be able to find our Y. So how do we go about doing that? Okay, we know this is a rhombus. Rhombus also has parallel lines, right? So in between parallel lines, they always add up to 180 degrees. So this is not just a property for trapezium itself. It is for parallelogram. It is for rhombuses as well. Okay, so if this angle here is 72 degrees, what is on the other side? It's just 180 minus 72. That gives you 108 degrees. Okay, on the other side. And if that angle is 108 degrees, what else can we find? Half of it is actually 54. Why? Because this BF is the diagonal of the rhombus. Okay, and remember, diagonals of rhombus always cut the angles at one point of it, at the corner, into two equal parts. So if this whole thing is 108, half of it is 54. Once we have that, this is angles on a straight line. Okay, so 180 degrees minus away that 54, we have the angle up here, 126. This is our aim, right? Once we have this, make use of isosceles triangle, okay, and then we can find angle Y. So FG equals to FH. So to find the bottom angle, just take 180 degrees minus 126 degrees divided by 2. That gives you your part A answer, 27 degrees. Part B, angle Z. Okay, we have A already. We have part A. We have the other angles that we try to find along the way. And then part angle Z is over here. Okay, it's part of the trapezium here. So what we need is angle CBG. Where's your angle CBG? Over here. Okay, it's actually opposite the angle CFG. Okay, and remember, angles that are opposite each other in a rhombus, they are equal. So this angle here is 108 degrees as well. Okay, then what do we do? This angle here, okay, BGD. Okay, this small angle here, BGD, is actually the same as, okay, sorry, not BGD. BGF is actually equals to angle BCF as well, because they are also opposite angles. So if this whole thing is 72, to find this smaller angle here, okay, BGD, that is 72 minus 26 degrees. What is the purpose of finding these two angles? It is for this triangle BDG. I have two angles inside BDG. I can find this angle BDG here. Okay, and my angle BDG is just angles in a triangle, 180 minus 108 minus 46. That gives you 26 degrees over here. Okay, once we have this, we know that this is a trapezium. What is this line and this line? Parallel to each other. And angles between parallel lines, they add up to 180 degrees. After angle at the bottom, I can make use of the 180 degrees minus away. That gives me my angle Z. Okay. So 180 minus 35 minus 26, which is below, that gives me 119 degrees for part